In the previous discussion, we have learned how to write an equation of a straight line. In the following discussion, right, our objective is to know how to interpret the ratios and the rate of change. Okay, now we're back to the slope again. So the slope, right, it is actually can be interpreted as either a ratio or a rate. Now, when the x and y, they are in the same unit of measure, right? So the same x and y, same unit. So we say the slope represent a ratio. If the x and y, they have different units, so we say the slope is a rate of change. Okay, so let's see the two examples right below. Now, the example 2 here, all right, shows that we using the slope, we interpret the slope as a ratio. Okay, now the maximum recommended slope of a wheelchair ramp is 1/12. Now, what does that mean? It means that, all right, for wheelchair ramp, all right, it's supposed to be if you have, all right, 12 feet here. 12 feet, all right, the distance, the horizontal distance is 12 feet. The vertical distance should be 1 feet. All right, so therefore, this is easier for the OKU to actually go up the slope. Okay, so this is the ratio. Now, a business install a wheelchair ramp that rises to a height of 22 inches over a length of 24 feet. All right, so this businessman, they want to, or business firm, they want to install the wheelchair ramp. All right, so the horizontal distance is 24 feet. And, all right, the height is actually 22 inches. Now, so is the ramp steeper than the recommended one? Okay, so what do you think? All right, so to find this, we can actually use the slope. All right, so first we find the slope of the ramp by using the difference of y, the rise, over the run, right, the difference of x. Now, we have to change them to the same unit because the feet, all right, and the inches, they are the measurement for distance, right? So then we can actually change them to the same unit, right? The 24 feet is 288 inches. Okay, now just for your information, 1 feet is equivalent to how many inches? All right, it's equivalent to 12 inches, right? 1 feet is actually 12 inches. So 1 feet is 12 inches. Of course, 24 feet will be 24 multiply 12 inches. So we can see here, all right, 12 minus 24, and so it's 288 inches. Okay, now we have the difference of y is 22 inches, and the difference of x is 288 inches. Okay, so right, approximately we get 0.076. So this is the slope for the ramp. Now, for the recommendation, it's actually 1/12. So 1/12, if we use a calculator, change it to decimal, is approximately 0.083. Okay, now, so then the ramp is not steeper than the recommended one. Now, when the ramp is not steeper than the recommended one, so let's say this is a recommended one. All right, now the business firm, okay, install the ramp is not steeper than the recommended one. So do you think this is suitable for the OKU? Right, yes. Right, so it's suitable for the physical challenged person. All right, so now this example actually just want to show us that the slope is actually a ratio. All right, the slope has no unit because, all right, in these questions, both are inches, and when we divide, all right, the unit has been eliminated. All right, so it's a ratio. So this ratio actually shows that when the x is different by 1, right, the horizontal distance is different by 1, the difference is 1, the difference of y is 0.076. Now let's look at another example to interpret the slope as the rate of change. Okay. Now the population of Colorado was about 4,302,000 in the year 2000. Alright, and the population is 5 million plus in the year 2010. So we need to find the average rate of change of the population over this 10 years period, right? So what is the average increase of the population over the 10 years period? So what will the population of Colorado in the year 2020, okay, this year, right, assuming that the Colorado's population continue to increase at the same rate. All right, so now the first we need to find what is the difference. Okay, now what is the difference of y? Now here we can actually take the y as the population. All right, and we take the x as the difference of year. So in this case, we can have, all right, the year 2000. Now when the year is 2000, we take it as 0 year because we start counting, right, at this year. So when the year is 2000, all right, we say it's 0. What is the population? The population is 4,302,000. Okay, 4,302,000. Now after 10 years, all right, so this is 10 years. So the population is 5,029,000. All right. So now what is the difference of population? Okay, the difference of y, the difference of population is actually 5,029,000 minus this. Okay, and the difference of years will be 10 minus 0, so 10 years, the difference. All right, so this is the difference of y, and this is the difference of x, which is 10 years. So we can proceed with our calculation here to find the average growth. Okay, average growth of the population. Right, so now after we complete this calculation, so it's approximately 72,700 people per year. Okay, so when we plot in the graph, it will be something like this. When the year is 2000, right, this is the amount, 4 million plus, and at 2010, right, the population is about 5 million plus. So over the 10 years period, the population have increased 727,000. Okay, now so when we want to find the population for the year 2020, right? So we know that, right, from here another 10 years, okay, another 10 years here, what happened? What happened to the population growth? It will grow another 727,000 again, right? Therefore, right, for the year 2020, this year, all right, we are going to add another 727,000 to the 5 million here. So we will have 5 million 0.029000 plus another 727,000, and this will give us this value, all right, 5756. All right, 5,756,000. All right, so this is how we actually use the slope, all right, to find the growth for the population. Now, please bear in mind that this example is to show us that the slope represents the rate of change. Now, the rate of change refers to when the year increased by 1, okay, per year. When the year increased by 1, the population increased by this number, right? So we call this the rate of change. Okay, so the example shows us that the slope represents the rate of change.